How come it's not C?
Oh, okay. How come it's not C? It just isn't. It reads in the whole string. So, so what it does is it grabs the word just as if you had called next. It's exactly as if you had called next. And then it tries to convert the result of that. So it grabs the whole string, 6,995.00, tries to convert the whole string to a double. Yeah?
So when you're in the double, it's not like the comma, it's the next.
No. That's what I'm saying. It has no conception. In the book, there's an example where it tries to read in like 21 ST. And it'll read first the entire string, just like that, and then it'll try to convert the entire string, and it'll say, that is not an int. That's not a number.
But it'll still accept the 21.
No, it will not. As unbelievable as it may sound. The programmers who did this, I think, were lazy. They just have this concept that this thing eats tokens. And they say a token for a scanner is anything that's delimited by white space, any word. And so when you call next int, it first calls next, and then it takes the result thereof and tries to convert it. It does not try to find the minimal sequence of digits like it works in C or C++. It is different. I'm not saying it's better or worse, it's just different, and once in a while you do need to know that difference. All right, a couple of input tricks. So as a general thing, when you have a fairly complex input, and the input is somewhat line-oriented, such as it is for example, homework 3B, where the lines do matter, but they have internal structure that also matters. The winning strategy tends to be to read in a line at a time, and then to take the lines apart further. I've seen a few things on Piazza where people were trying to do adventurous strategies on changing the delimiter of the scanner, and I would not change that delimiter in midstream and then try to change it back. That sounds like a very dangerous thing to do. So generally, if you are in that situation that the input is very variable, you're better off reading it in at a line at a time and then analyzing what you've got. In fact, it's perfectly legitimate if the input is not line-oriented to just read in all lines and concatenate them into one humongous line and then analyze that. That often is still better than reading it with the scanner. The scanners are not all that flexible. So, but for the homework, definitely for the first two, read in a line at a time. That'll work. Now, then you do get this long line that has internal structure, that has some digits in it, some numbers, and some things that are not numbers. And then the question is, how do you take that apart? One way of taking it apart is, of course, with the string methods. Trim is something that you'll do a lot because oftentimes you get something that has some white space in the ends and you want to get rid of that white space. You might have to find where to break that line up. You might have to look for spaces inside that line or for commas or whatever it is that a particular format looks for, and then index off and last index off are your friend. They find the first or the last index of some occurrence. And so oftentimes you find the first one, you break it up there, you call it again, and you keep breaking it up in that way. Another thing you can do is you can look at the line a character at a time. And then how do you make sense of these characters? The character class has a whole bunch of nifty predicates. Is digit, is letter, is white space, that you might find helpful. And now here's another nifty trick that works beautifully for homework 3A, where you read in a line. And so let me just run with this example, which is perfectly good. So here I'm reading in a line that contains the name of a country, the United States, followed by some large number. It's not large enough for the national debt. Maybe it's the population. And then I want to take that line apart further. Now you can make a second scanner. That's what I'm doing here. And you can make a scanner out of any string. It doesn't have to be a file. When you make a scanner out of a string, then it reads the characters in the string as opposed to the characters in the file. And now I can read them with the same familiar scanner interface. So I can call next, and that gives me the next word in here. So at this point, it would give me united. Now, I have to make a decision. Should I call states? I mean, should I grab the states? Or when should I start looking at this thing as a number? And this is where these has next functions are nifty. So I can say, while the next one is not a double, so it's willing to peek ahead at the whole next token and tells me whether it's a double. While the next one is not a double, I'll just keep concatenate that with the country. And that way I get United space state. Or if it said United States of America, I would get United space States space of space America all together. And finally, when it is a double, then I can call next double, and I can read it in. So that works fine. Now you might say, why didn't he just use double parse double? There is a function double parse double that takes a string into a double, but double.parse double always makes me a little nervous, because if the thing inside is not a double, then it throws an exception. Whereas with a scanner, I have the choice of asking it. I can say, are you seeing a double? And so that's not an option that you have with double.parse double. So that secondary scanner trick is often very useful. I used that secondary scanner trick in homework 3A to good effect, and the code became very simple. All right. Finally, once in a blue moon, you do want to change the delimiters on the input. For example, if you want to have a file like Alice in Wonderland, and you just want to know how many actual real words are in there, and with words you mean things that contain A to Z, not punctuation marks or anything that might be glued on to a word. In that case, you can turn the delimiter to the regular expression, say anything that's not an A to Z, I want that to be a delimiter. But that doesn't happen very often, and I would think twice before using that, particularly in the homeworks. Yeah, I don't see that in any of them it's going to be helpful. So once in a while, you'll find that you can get away with it. But the truth is that most file formats that have any real information in there are sufficiently intricate that it's just not going to work for you. So the standard thing is that if you have a complicated file format, the standard thing really is to call next line, and then use string methods or these secondary scanners to take the input apart. Okay, we have another clicker question. Let me see whether by any chance yeah, the heck's my scroll bar. Okay, here's the question. Oh, huh? What happened to my question? Okay, somehow this question got munged. Okay, never mind. I'll erase it. All right, just leave it open. Okay, let's try to understand what question I meant to ask. So we want to read a line. So let's home and right on the line that gives us the problem. That's this one over here. We look at the last index of Oh yeah, this would have been a beautiful question if I just had gotten it right. So we look at the last index of a space that gives me this position here. We take the substring from 0 to n, that's the name, and then we take the substring that goes from here to the end, and then we call integer.parseInt on the last one here to get the age. So again, in slow motion, I have the space here. That's the last space. Here I have the 30. This is my position n, and so here's my first substring, and here's my second substring. So what goes wrong? Something really goes wrong. Yeah, the problem is this space here. Notice that the second substring includes the space and the number 30. And when you call integer.parseInt with something that's not an integer, even just that little space is considered not an integer, then integer.parseInt will throw a fit. It'll throw an exception and you won't get your result. Is there a question back there?
Did you do a quick fix of quick n plus 1?
Yes, so the quick fix number 1 is, of course, to put in n plus 1. And that really is the correct thing to do, right? Because that's what I want. The other quick fix is to call .trim before calling integer.parseInt. So I reflexively call .trim just because I'm nervous. And yeah, it's one other method call. But yeah, so the correct thing is, of course, to do n plus 1. It's easy to mess up with these indexes, n versus n plus 1, when you take strings apart. All right. Okay. That's too bad. That would have been a great question. All right. So that's all I have to say about input. It's not really conceptually difficult to process input, but it's often algorithmically difficult. You have to come up with some strategy on how you deal with the various pesky cases. And so for this homework in particular, I think it's a really good idea to first come up with an algorithm for the 3 different problems. There are going to be 3 different ways of attacking them. To come up with an algorithm and really understand your algorithm with its complications in various cases. Grab a friend and talk it over with them, just how you would do it by hand. Because once you start coding, then you're down this rat hole where you have a mess of special cases, and you already have all your code written, and you're going to be very reluctant to change it, even though you've chosen maybe a bad strategy, and then it's going to be miserable. So with these ones, it's so much easier if you approach it the right way, and that you're confident that the implementation is just a detail. You have a question there?
Does it matter if you do the
This one?
Yeah, does it matter if you do the statement before or after?
Oh, I see. Okay, that's a great question. Let me do the lead-in into exceptions, and then I'll tackle it. So we have 4 sections, 1 today and 3 on Thursday, on exception handling, and it's a very important topic. So there's 2 parts to exception handling. One is to detect an error, and the other one is to notify the system that there is an error. And error detection is kind of tricky. We'll deal with that on Thursday. But it turns out that error notification is really, really simple. So as soon as you find that something is very, very wrong, that's not the way it should be, what you should do is you should stop processing in the normal way and throw an appropriate exception. So over here, if the amount is greater than the balance, we don't want to withdraw. Instead, we throw this exception. Now what that means is that this statement here will never be executed. Or the other way around, that this statement will only be executed if there is enough money in the bank account. And so to answer your question, you will definitely want to first check and bail out before you do the subtraction, because then there's an ironclad guarantee that balance will never be negative. Otherwise, you would be in a situation where you first mess up and then you notify someone that you have just messed up, and that's not as good. Now I realize that Bank of America will first subtract and then send you a fee notice, but that's different, right? They're not interested in maintaining the integrity of your bank account. They're interested in maintaining the integrity of their bank account, and that's an entirely different thing. So when you have any kind of data structure, and we're just using the bank account here as an example, as you'll see later in the semester, data structures can be finicky little things. They assume that certain values are in certain relations with each other. And before you get them out of whack, you just want to say, I'm just not going to do this. Get me out of here, and throw an exception. So it's kind of the nuclear option. You say, I'm just not going to do it. I'd rather die. Now, in a real program, of course, you won't die because there'll be someone who will catch that exception and do something appropriate, just as tell the user, things are really not working out today. Can you log in another day? Or whatever it is that's an appropriate action. But when you throw an exception, you want to say, if things are so bad that you can't really continue, if you otherwise would be forced to divide by 0 or look up an element that's null or something, you're better off throwing a reasonably meaningful exception so that someone else can take care of the problem. There's no shame in throwing an exception. So there's a whole hierarchy. There's dozens and dozens of classes that are designed for your exception handling pleasure, and your job is just to come up with one that's a good match. So, in fact, that's this clicker question here. And let me see, can I rescue? Maybe I can do this here. Oh. How come people answer this when it wasn't even complete? All right. And how come people said C and D when there wasn't? Whatever. All right. Okay, so this is a perfectly good question. So what are we doing here? So this is the smallest method that we've seen from a previous lecture. We're looking at the smallest of a number of values in an array. So we're getting the array, and I'm checking for the case that the length of the array is 0, because if it is 0, then this call here would lead to an exception. And so I want to not do that. I want to replace that with a more meaningful exception. And so I give you 4 choices. Which one of them do you think is the best option? Oh, I see. I can't do that. All right, let's see. We have 45 votes. Okay, this is not rocket science. It's just how do you feel about this? There's no one right answer. It's a total judgment call, which I think entitles me to more than 61 answers. Okay, it's not entirely a judgment call. There's one answer that's bad. So what exception would be thrown if I didn't put in this guard? If I just let stuff happen. Now someone calls this thing with an array that is empty, that has no elements in it. Oh, actually, can you ever have an array that's empty? Can you make an empty array? Yeah, sure. You can just make an array of 0 strings. And it sometimes happens as a special case. Like if you have a method that gives you a result back, and it looks for all matches and it finds no match, then it'll just be 0. All right, so in case that, how are we doing here? Fine. In case that nothing at all is done here to protect this code, then the thing comes in here, we're not having this check, we're looking at values bracket 0, and what exception will it throw? This thing will throw an array index out of bounds exception. So we're not adding any value if we also throw an array index out of bounds exception. There's no point in throwing an array index out of bounds exception if the next line would throw that exception anyway. So for us to add value, we have to throw some exception other than A, which sadly was the majority choice. So no one chose an illegal state exception, and that's fair. An illegal state exception means in something that has some kind of state where it acts differently, like a container that when it's full rejects things, for example. But this is not a stateful situation here. So an illegal argument exception, I guess that makes sense because you weren't supposed to call it with an empty array. It makes no sense to ask what's the smallest element in an empty array. And the other thing that also makes sense is a no such element exception, because if you're asking for find me the smallest element in an empty array, there is no such element, and so that would make sense just as well. So both of those answers are perfectly correct. The only thing is that what you should be doing when you write the Java doc, you should be indicating in the Java doc what kind of exception might get thrown when. That way the reader, when they get one of these exceptions, then they know what's going on. All right, that's all you need to know about throwing exceptions. Throwing exceptions is dead easy. You find something wrong before just inscrutable exceptions or random results or garbage happens. You look in that catalog of the 20 or so exceptions in that diagram. You pick one that's appropriate, and you just throw it. It's always a good idea to put some text in it, like here, so that the text helps whoever reads the exception message. All right. So in the lab, we'll continue the command line stuff. I updated the buddy list a little bit, which is here. Oh. The ones with the asterisk in front have changed. The other ones stayed the same. So have a quick look if your name has an asterisk in front, and if so, find your new buddy. Otherwise, just keep on going. Hopefully that'll be the last change for the semester.